Our topic for today is triangle. A triangle is a polygon with three sides. Parts of a triangle. In this example, triangle ABC has three sides, three angles, and three vertices. The three sides are sides AB, side BC, and side AC. It also has three angles, angles ABC, which is this one, angle BAC, which is this one, and angle BCA, which is this one. The notations I'm using indicate that the angles are not congruent. If the signs or the symbols that I use are the same, it indicates that those are congruent parts. So going back, there are also three vertices, and those are vertex A, B, and C. Now we go to the secondary parts of a triangle. These are altitude, median, and angle bisector. The altitude is the perpendicular segment that connects a vertex of a triangle to the line containing the opposite side. Let us begin drawing this. So if this is my first vertex and I want to draw the altitude to this opposite side, I will have to connect a perpendicular segment from that vertex to the line that contains this opposite side. In this case, I will have to extend it because the altitude will be found here. We will approximate this to be the perpendicular segment. So that's one altitude. We're going to assume that that is 90 degrees. The second altitude will come from this vertex, and we will draw a perpendicular segment through here, and we will assume that this is 90 degrees. My next vertex is this one, and this vertex has the opposite side here, but we will connect it to the line that contains that opposite side. In this case, we will have to extend it to here. And so the altitude for line segment XY through vertex Z is going to be this one right here. And we will assume that that is 90 degrees. So here's the definition of the altitude, and this example is for that. We now go to the second one, which is the median. The median is a secondary part of a triangle that is a segment that connects a vertex of a triangle to the midpoint of the opposite side. So let us begin. So in this case, if we have this segment JO or side JO, I would connect this to the vertex Y, and I would assume, let's approximate, let's say that that's a midpoint, which means this is congruent to that. If I connect that vertex to that midpoint, then that's called my median. There are three medians because there are three opposite sides and there are three vertices. So for the O, I will connect it to approximately here, where this is congruent to this, and that is the other median. And then for J, I will approximate that it is about here, where this is congruent to this, meaning that that's the midpoint, and I will connect that vertex with that midpoint. And there you go. Those are my medians. Okay, so just to mention to you, the point of concurrency of all the medians has a special name, and it is called the centroid of your triangle. The next secondary part is the angle bisector. The angle bisector is a segment that bisects the angle of a triangle. So therefore, there are 3 angle bisectors. So let's begin by bisecting this one. We will just approximate. We'll kind of say that this is congruent to that. And now we will try our best to bisect this. That this is congruent to that. Okay. And then we'll try to bisect this as well. Again, similar symbols or similar marks that you make means that your angles are, or your parts are congruent. So that means that this angle is congruent to this one, this is congruent to this one, and this is congruent to that one. The concurrency, or the point of concurrency of all the angle bisectors, also has a special name, and this special name is called the incenter of your triangle.